Hi there. Welcome to my base room classroom. I had some help getting this all set up, so I thought we'd try and do a few problems here on the whiteboard. And if it doesn't work out so hot, like if you can't read my writing, or if it's easier for us to use OneNote, we'll just go back to doing that. But I thought this might be kind of fun to give it a try. Okay, so welcome. And we are going to take a look at a couple of things today. We are going to take a look at converting a quadratic that is in standard form to vertex form by graphing it first. And then we also will take a look at converting a quadratic that's in vertex form to standard form. We'll see if we can all fit it in kind of a short little presentation here. Okay, so here we go. So we're going to start with the equation y is equal to x squared minus 8x plus 12. And hopefully you guys can see that okay. So this is in standard form. So we know standard form is going to be the form y is equal to ax squared plus bx plus c. So we've talked about that quite a lot. And so one of the things I like to do right away is to identify your values of a, b, and c. So right here we're going to say a is equal to 1 and b is equal to a negative 8 and c is equal to 12. And we did talk already about in standard form that this key feature of c being equal to 12 should let you know where the y-intercept is for this graph. Okay, so that was one of the key features in standard form. Another thing to be looking out for was our a value, remember, because our a value can tell you whether the graph is going to open up or whether the graph is going to open down and how wide or skinny it is, right? So the stretch. So for this particular problem, the a is 1, so it's going to be opening up, and it is going to cross the y-axis at 12. So we can kind of start to look at what that might look like graphically. So I'm going to go ahead and draw that picture over here. And then we are going to, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're just going to put that point right there. Hopefully you guys can see that okay. And we're going to use our formula for finding the value for the vertex, not only to continue to graph, but also to change the standard form to vertex form eventually. Okay, so we're going to find the x value of our vertex by taking negative b and dividing it by 2a. And because you have your a, b, and c values over here already, we can just plug in our values of b and our value of a to get the x value for our vertex. So it's the opposite of b. B was already negative, so it's negative times negative 8, which is going to make this a positive 8, over 2 times 1. And that's a nice little 8 divided by 2 that gives us a value of 4. So that worked out really, really nice. Our x value is equal to 4. So we're going to go ahead and draw that. And because our x value is equal to 4 for our vertex, that means x equals 4 is our axis of symmetry. So we're going to go ahead and draw this axis of symmetry right down our graph right there. Hopefully you guys can see it pretty good. We may make it a different color just for the fun of it. Let's try that so you can kind of see it even a little bit better. So x equals 4 is your axis of symmetry. Now we're not done yet because we know the x value of the vertex is 4. We don't know what the y value of the vertex is yet. So what we're going to do is we're going to take this 4 and you're going to plug it back into your original equation. So you're going to plug a 4 in here and a plug a 4 in here. And that is going to give us our y value of our vertex. So let's try that. We know x is equal to 4. For our vertex, this is going to be 4 squared minus 8 times 4 plus 12. Okay, and if we're real careful with that, our 16 minus 32 plus 12 looks like it's going to give us 28 plus a negative 32. So y is equal to a negative 4. So as you've worked through this problem, you've used standard form to do some of the following things. You've used it to evaluate the y-intercept. That's our c-value. You've used it with the formula negative b over 2a to identify the x value of the vertex. And you've plugged things back in to find the y value of the vertex. All right. So that means our vertex is at x equals 4. There's our 4. Y equals negative 4. So I'm going to go ahead and graph that. So here's 4, negative 4. 1, 2, 3, 4. And we knew that our parabola is opening up because our a value is 1. We also know that our parabola has symmetry, right, over that axis of symmetry. So not only is 0, 12 a point on the graph, but also if you come back over on this side, then because this is 4 away here, if we count 1, 2, 3, 4 away, then 8, 12, that point right there, if I can mark it, is also going to be a point on your parabola. Okay, so this is what our parabola is going to end up looking like. Check this out. It's going to come down all the way down through here, through 4, negative 4, and shoot right up through there, just like that. Okay, we're not quite done. All right, we're going to add one more thing, so that you know how to use this process to write an equation in vertex form. All right, so really all you need for vertex is the vertex and your a value, and we have those two things. So I'm going to show this to you real quick, and then on some more specific notes on OneNote in a different video, we'll go through a little bit, a few more examples of writing problems in vertex form. But here's the one I wanted to show you for today. So your a value is 1. Your vertex is 4, negative 4. And for vertex form, we call that the h and the k value. So this is our h value. This is our k value. And we are going to plug things in. All right. So last step. Here's our formula, vertex form. Y is equal to a times the quantity x minus h squared plus k. So we'll plug those things in and you'll be able to recognize where you see the vertex in vertex formula from now on. Okay, so here it is. Y equals 1, a is equal to 1, x minus 4 squared plus k, but k is negative, so it's going to be a minus 4. All right, so that's how you take your standard form, roll through graphing it, and change it over to vertex form. It's tricky. It's going to take some practice. We'll do some other problems for sure, and hopefully you guys were able to kind of follow me through this okay, and we'll have to get together and talk about if this was helpful, or if you'd rather have me doing some examples, not in my basement classroom, but in other places instead. So take care, guys. Keep working hard. You're doing a great job, and I'll see you soon.